Rexa actuators are relatively simple mechanical machines with a sealed, closed-loop hydraulic system that eliminates oil quality concerns caused by exposure to its environment or duty. They are equipped with a local solid-state control system that monitors and diagnoses its operation. When abnormal operation is identified, local inspection and observation will provide details for determination of the problem. The control module, feedback module, and front termination panel contain live electrical wires. Do not loosen any fastener, plug, or port, as the unit may be under high pressure if it is in operation. Keep tools and hands away from moving parts, as there will be no warning if the actuator must move while in service. The Rexa actuator contains an oil reservoir that provides an expansion volume for oil as it heats up. The spring-loaded piston moves outward along a level scale to indicate the status of the reservoir. Some leakage or weeping is expected after initial or post-overhaul installation of the actuator. Continuous leakage, while not indicating a hot level, represents damaged seals somewhere in the actuator. If the oil level is low and refills are performed with no indication of external oil leakage, the actuator will require lockout, as it may be leaking within the internal wire passages accessed through the front cover or into the gearbox in the rotary model Rexa. Eventually, the oil will leak externally. If this is the case, the motor inner and outer seals or rotary cylinder piston seals may have failed. Leaking piston seals or a faulty flow match valve is evident when the actuator is not maintaining position while the process is pushing on the attached device. A visual inspection will indicate that the motor will operate intermittently in one direction to maintain position. Check that the bypass valve is closed. It is a passage between both sides of the piston and will cause the motor to operate periodically to maintain position. If the motor is turning in both directions, it is an indication of a controls problem where the controls are hunting for a set point. Refer to the I&C department for correction if this is the case. Leakage at the lower or top bushings indicates a problem with alignment of the actuator stem and valve stem, which causes a side load on the bushing seals, piston seals, and bushing O-rings. Leaks at the seams of the actuator gauge manifold, hydraulic block, and motor indicate a fail of the O-rings between them and the power module. If the motor is operating but the stem is not moving or moving too slowly, the system may have air and will require purging. The pressure gauge will show erratic pressure readings. If no pressure is present when the motor is operating, the suction check valves for the reservoir may require replacement. If there is mechanical binding where the piston stem will not move, check the pressure. It should indicate 2200 to 2400 psig in the direction of travel. The existence of pressure will indicate that the driven device is causing the lack of movement and will require repair. No pressure with the motor moving will indicate a mechanical hydraulic fault in the powertrain, cylinder, or a broken coupling. If the valve is not fully closed, check the position of the elastic coupling. The indicator should be in the middle. If the indicator is at the bottom, power down the actuator and, using the hand wheel, Attempt to close the valve further until the indicator is in the center position. Pressure will increase on the gauge. This actuator will require readjustment of its zero set point. If the indicator is at the top, power down the actuator and, using the hand wheel, attempt to move the stem upwards, as this is an indication the valve is driven too far and damage may have occurred. To determine whether a problem is strictly mechanical or electrical, power down the actuator and operate the valve with the hand wheel. If the actuator works correctly, all mechanical components are operating properly. For any condition to include problems with feedback signal, drive signal, faulty motor, upper and lower limit stops, or solid-state cards located within the control module, alarms will be provided on the display panels. The electronics also record the amount of position changes that the actuator makes and how many times it has cumulatively stroked. These diagnostic parameters are called starts times 1K and strokes times 1K. Each start indicated equals 1,000 starts. These conditions are monitored by the Control Circuit Diagnostics and should be reported to the Plant INC department. Refer to the specific actuator manual for determination of alarm codes.